How is a diamond, one of the most ordered and pristine substances known, fundamentally related to the chaotic mix of gases in the air we breathe? How is a perfectly clear glass of salt water, which appears uniform to our eyes, profoundly different from a glass of ultra-pure water? The answers lie not just in what these things are, but in how we, as chemists, systematically classify them. Today we are going to explore the foundational sorting system for everything in the universe, the classification of matter. This isn't just about putting labels on things, it's a rigorous framework that dictates how we analyze, separate, and understand any substance. It's the first and most critical step in any chemical investigation. All matter can be divided into two primary categories: pure substances and mixtures. The distinction between them is absolute and hinges on one critical question: can it be separated by physical means? A mixture is a physical combination of two or more substances where each component retains its own chemical identity and properties. Think of a salad. The lettuce is still lettuce, and the tomatoes are still tomatoes. You can physically pick the tomatoes out of the lettuce. This physical separation, whether it's by filtration, distillation, magnetism, or simply using forceps, is the definitive characteristic of a mixture. A pure substance, on the other hand, has a fixed, definite chemical composition and a unique set of properties, like its melting point or density. You cannot separate pure water into anything else by boiling it or filtering it. You will only ever get more pure water. To break it down further requires a chemical reaction. This distinction is paramount in fields like pharmacology, where a new drug, a pure substance, must be rigorously isolated from the complex mixture of a plant extract before it can be studied. Now let's look closer at the world of pure substances, which are themselves divided into two classes. This division is based on another question: can it be broken down by chemical means? An element is the ultimate building block of matter. It is a pure substance that cannot be decomposed into a simpler substance by any chemical reaction. Why? Because an element consists of only one type of atom. The element iron is made of nothing but iron atoms. We can see all the known elements organized on the periodic table, our ultimate catalog of these fundamental materials. A compound, however, is a pure substance composed of two or more different elements that are chemically bonded together in a fixed, definite ratio. This is a profound concept known as the law of definite proportions. Water, H2O, is a compound. It is always 2 parts hydrogen to 1 part oxygen by atom. If that ratio changes, it is no longer water. Furthermore, the properties of a compound are unique and bear little resemblance to its constituent elements. Hydrogen is an explosive gas, and oxygen is a reactive gas, but when chemically bonded, they form water, a stable liquid essential for life. Returning to mixtures, we can also classify them into two types based on their uniformity. A heterogeneous mixture is one whose composition is not uniform. You can see distinct phases and boundaries with the naked eye. In a mixture of sand and water, the properties of a sample taken from the top are very different from a sample taken from the bottom. A chocolate chip cookie is a classic example. One bite might have 3 chocolate chips, while another has none. A homogeneous mixture, also known as a solution, is perfectly uniform in composition down to the molecular level. When you dissolve salt in water, the sodium and chloride ions are evenly dispersed among the water molecules. Any drop of that salt water you sample will have the exact same composition and properties. This category isn't limited to liquids. The air we breathe is a homogeneous mixture of gases, and alloys like brass are solid solutions of copper and zinc. The key difference often comes down to particle size. In a true solution, the solute particles are individual atoms, ions, or small molecules. In heterogeneous mixtures like muddy water, a suspension, The particles are much larger and will eventually settle out due to gravity. Let's put this framework into practice. Imagine you are handed a beaker containing a murky mixture of sand, salt, and water, and your goal is to isolate all three pure substances. Your classification of the matter is your roadmap. First, you identify the entire beaker as a heterogeneous mixture. You can see the solid sand distinct from the salty water. To separate them, you use a physical method, filtration. The sand is trapped by the filter paper, and you have now isolated your first pure substance, sand, which is the compound SiO2. What passed through the filter is a homogeneous mixture, salt water. To separate its components, you can use another physical method, distillation. By boiling the water, you separate the gaseous H2O, a compound, from the solid NaCl, also a compound, which is left behind. Notice that up to this point, we have only used physical changes. If we wanted to go further and break down the compound water into its elements, hydrogen and oxygen, we would now need to employ a chemical change, such as electrolysis. This entire process, from a complex mixture to its fundamental elements, is guided by our systematic classification of matter.